Hi everyone, welcome to my YouTube channel Networking Made Easy by T.S. Srinivas. So, in continuation with our lecture series on guided transmission media, so today let us discuss yet another important media that is nothing but the optic fiber. Okay, so this medium, the optic fiber, has created a revolution in the race of computers and communication. So the optic fiber has created a revolution in the communication industry actually. So generally you see whenever we have discussed in the transmission process, the transmitter, receiver and the medium, you see we can put a lot of intelligence, means you can do research and bring some new technologies as far as the transmitter or receiver is concerned. But whereas the medium is concerned, it's a physical medium. Okay, you cannot bring technology into the medium. So you have to search a natural resource. Okay, so that's how a very good medium we got, that is nothing but the optic fiber. Okay, so generally, see, always in the communication process, the biggest bottleneck is the bandwidth. Okay, so this has been overcome like anything with this particular medium, optic fiber, because the bandwidth, the present bandwidth available in the optic fiber is unlimited in the sense it is in the terahertz region. So, because to make good use of this particular bandwidth, we have so far not developed the technology to make the best use of this particular bandwidth. So that's how you can understand the life of this particular medium. This medium is going to exist for a very long period. So what mediums we have seen in the earlier copper medium, see, there is a restriction, the bandwidth restriction. It's very carefully you are handling, because that was a bottleneck. If you want to improve your transmission or receiver technology, the medium was troublesome. So now that has been overcome by using the optic fiber. Okay, so you just, to understand what is basically optic fiber, you just see, because basically the information what is traveling in the optic fiber, that is in the form of a light. Okay, so now just recollect in the RF session, RF spectrum session, what we are discussed. See, so far we have been talking in terms of frequencies. Okay, in the RF frequency spectrum. So there I told that we have seen up to the infrared rays. Then after infrared rays, you have a visible light. Okay, so as the frequency keep increasing, the wavelength is decreasing. Okay, so now in this particular optic fiber medium, the information is traveling in the form of a light. Okay, so here now the main, if you want to simple understanding as far as the construction of the optic fiber is concerned, so the main part is the very minute thing, the center part. This is nothing but the core. Okay, it is made of a silica glass. It's a glass tube. Okay, so it's a hairline structure, very thin, very fine glass tube. The light is traveling through this particular tube. Okay, so the dia of this particular core. Okay, so now in this particular optic fiber, we have two modes. That is, one the single mode and the multi mode. So see, to understand better, in the single mode means one single light, it's a fine focused. Okay, so that's the reason the dia of this in the single mode is in 9 micrometers, very minute. Okay, so that the light, only single light is traveling through the tube. Okay, so whereas in the multi-mode dia, the dia is little bigger. So the multiple wavelengths can travel through this particular core. So specifically, as far as the usage is concerned, the multi-mode fiber used for a very small region with a high power. But for a long distance communication, see, always the single mode fiber is being used. Okay. So to understand further as far as the construction is concerned, so above this you have another covering, that is nothing but the cladding. We call it as a cladding. It is a solid glass. To understand this better, like it is working on the principle called total internal reflection. See, basically whenever the light travels from a rare medium to denser medium, so it is tend to bend because of the difference in the refractive index. So that's a principle. So what is being utilized in this particular optic fiber is, so when the light, incident light, okay, into the glass, is the angle of incidence is more than the critical angle, so it is bending so much that it is staying within the core. Okay, so that's why when it is when it is hitting and it is means put into the core itself, again it is reflected back, so that it is traveling within the core. Okay, this particular concept we call it as a total internal reflection. Okay, so that's how the light is, the basic purpose is the light is kept within the core. Okay, so outside the cladding, what is there, its refractive index is lesser than the main core material. Okay, so further you have another primary coating. So it is, see ultimately the light has to not leave this particular fiber. So the light has to be within the core itself. So that's how the construction is made. So then further you have a primary coating. So this is also a plastic polymer, so that it is making sure there is a total protection for this particular cladding and the core. Then afterwards you have another strength material. Then you have a final jacket, outer jacket for this. So these are all for ultimate protection of this particular cable, so that the bending and additional strength for this particular optic fiber. So this is a small introduction about the construction of a optic fiber. Okay. So as we have seen in the single mode, the dia of the core is very small, that is in the terms of 9 micrometers, and multi-mode dia you have slightly bigger core, bigger dia. Okay. So further to this, as it is, we have discussed that it is having a extremely high bandwidth. So that is the biggest advantage of the optic fiber. And another thing, since the information is moving in the form of a light, so there is another big advantage. Whereas in the other medium like copper, the information is moving in the form of a electrical signal. So whenever the current is passing through a medium, generally what happens is there is a electromagnetic induction takes place. Since here information is passing in the form of a light, so it is immune to electromagnetic interference. Okay. Now another very important thing to be discussed is, see, since this particular frequency is frequency of light what is passing through the optic fiber, we always represent in the form of a wavelength. Okay. See, actually, generally the visible light wavelength is between 400 nanometers to 700 nanometers. It's a visible light. See, all of a sudden, you might be thinking in the communication, see, so far we have been talking in terms of frequencies. Suddenly, we have started talking in terms of the wavelength. Why? Because, see, as the frequency increases, it's a practice that we are talking in terms of wavelengths. Okay. So that's the reason, because the frequency is very high. So in terms of terahertz or petahertz, then we talk in terms of the wavelength. That's the only difference. Okay. When the signal was, when the wavelength was longer, so that time we have been talking in terms of frequencies. Now since here the frequencies are very high, so we are talking in terms of the wavelengths. Okay. Now it has been observed that, so what kind of light has to be allowed to pass through the optic fiber? So you see, because a lot of research has been done and it has been founded, so the attenuation is very less, because attenuation is less in the range of 850 nanometers or 1300 nanometers or 1550 nanometers, it is less. So it has been decided that if, see, this is not in the visible range, okay, these wavelengths are in the infrared region, okay. So that's how it has been decided that infrared rays with this particular wavelengths is allowed to pass through the optic fiber. Okay. So that's the reason. So the wavelength of this particular operation is in the infrared region. So the light source what is being used for transmitting the signal is either it is LED or laser. So now after understanding the construction of a optic fiber and its principle of working, okay, now you find, see, and there is no attenuation, it can travel without any attenuation for a very long distance. So because of this, what is advantage is you no need to require repeaters, okay, and what else, it's light in weight. So installation is, see, it's a one-time installation. Once it is done, it is well secured, okay, it's cheaper, like, you know, it is abundant, the glass, the silica glass means like it is abundant, means there is no deficiency, okay. So the carrying, transportation, these are all very simple, okay. So these are all added advantages as far as this particular medium is concerned, okay. So but when optic fiber has been introduced, initially this has been used only for long distance communication by the service providers. But later, they started extending into the access network. Okay, what actually is the access network is, see, service provider, he has to set up his own network, okay, for providing services to the customers. But finally, how he is extending services to the customer, so that is, we call it as access network. So sometimes we will be listening to the last mile, how actually the service is reaching to the customer. So the optic fiber is being used in the access network also. So that is what is the technology called passive optical network. Okay, passive optical network. Now you see, because see, earlier mediums also, when we discussed in terms of twisted pair cable. So why we have see, the twisted pair cable, the PSTN network, the twisted pair cable was used as a last mile, okay, the local loop we call it as, okay, how the voice service was being extended to the customer. So since already this network was existing, the service providers have decided to extend the data services also by using this access network. So somehow they were successful, and you have seen by using the ADSL technology, they could reach the maximum speeds up to 24 Mbps. Okay, but nowadays, so that's what the internet speeds are very important. The customer is asking for more and more speeds. So the dependency on the copper network, we cannot depend more on to that particular network. Now the time has come, the access network also to be replaced with a better medium. So that's the reason the optic fiber is being used to extend internet services to the customer. Now it's very interesting, you see, the PON technology, it works so wonder. Why? Because its bandwidth, the single optic fiber, the bandwidth is too good. Okay, so in terms of Gbps, so now from the service provider, you cannot extend every single fiber to each customer as it has been done in the case of a copper media. Like, because the twisted pair, for each customer, a dedicated line is running from the central office to the customer. But now it is not done that way, because the single fiber, what is running from the central office of a service provider, Okay. Service provider. See, definitely you have equipment, we'll be discussing about it. Okay. From here, from the service provider end to the customer end. So this is the medium. Okay. For each customer, you don't need to run a single specific fiber. So you can carry this particular fiber up to the customer end. Okay. Then there is a method called, you have a beam splitter. Okay. Here in this particular technology, we are using a single mode fiber. Single mode fiber. Okay. So it is carrying this particular signal up to the customer end. Then you are splitting this particular light into many. So that is what is the split ratio. See, for example, here we are splitting this particular single light into 32 different beams. Same thing. But only what you can see is the power is less here. Power, it is distributed into 32 different fibers. So now from here, each fiber is running to the customer because this is very close to the customer premises. You can imagine this particular fiber is running up to one particular apartment, say. Okay, from there you are having a splitter, a beam splitter in the ratio of 1:32. So 32 customers are getting this particular service. You can extend this service, means internet services, to the 32 customers. Okay. So it has been, because you no need to run a dedicated fiber for each customer. So that's how the cost has been reduced here. Now see, what very important as far as the service provider is concerned, see, whenever so it's a very costly affair installing all these particular things. So whatever the investment he is making it, he has to recover it. So that's how it is. So this particular PON technology is working too good in this particular aspect. Okay. So why? Because now here we are listening to the term called passive in the sense, see, this is a passive splitter. Passive in the sense it doesn't require any power. So only the end equipments require some power. So in between, this particular extension doesn't require any power. That is what is the big advantage of this particular PON technology. Okay. Now at the service provider, you have equipment called OLT. Optical line terminal. OLT stands for optical line terminal. So now this is actually working on point to multi-point. Point to multi-point. It is providing services to many customers. Okay. Now at the customer end, it is optical network terminal, or sometimes it is called as ONU, optical network unit also. Okay. Now what is being done here, you just see now. So there is a downstream, the light is traveling with this particular wavelength. It is a transmitter, it is having a transmitter as well as receiver. So at each ONT also you have a transmitter and a receiver. Fine. So it is transmitting with the wavelength of 1490 nanometers. Okay. Now this signal, whatever it is, this is download. Okay. At the speed of, means you can achieve the speeds up to 2.488 gigabits per second. So it's a huge speed. Now you see, this particular speed will be shared by many users, but it's too good speed. Okay. So now this particular signal, when it is reaching, because it's a passive network, so it doesn't know when it is traveling, it doesn't identify customer directly. So what it is happening, this signal, so-called what it is coming, it is reaching, in the case of a download, okay, it is reaching all the ONTs to all the customers. Okay. So here you can expect there could be a security issue as such, because why the signal meant for a customer should reach to all other customers. Okay, but it is well encrypted. So it is a data communication. You will be learning more about the packet switching. See, this concept you will be learning more in the networking concepts. But right now you understand this signal, whatever it is coming here, it is well encrypted. Okay, so the signal, whatever, see, suppose the receiver, it will pick up its own signal, that's it. Even though the signal which is coming, other signals are coming, other data information is coming to this particular ONT, it picks up its own and discards rest all. So that is the technique followed in the case of a download. So that's what, see the information how it will be. It is in the download, it is a time division multiplexing technique is being used. Time division multiplexing, already TDM you have learned, isn't it? So each time slot is allotted for each customer so that his information is reaching. Okay, but only the problem is all other customers' traffic also reaching up to this particular end equipment. But this equipment will pick up the information meant for it and discard rest all. So that's how all other ONTs also will be doing it. Okay. So this is as far as the download is concerned. Fine. Now similarly, in the upload, okay, now in the upload in the sense, now this has to transmit. The download means it is receiving. Now the ONT has to transmit. So it will be transmitting in the wavelength of 1310 nanometers. Okay. Who is going to receive it? The OLT has to receive it, isn't it? Okay. Now you have, here you see, when OLT is transmitting, there are so many receivers here. So there was no issue. So time division multiplexing is working very fine. Okay. But now here, so many transmitters are there. Who is going to receive? One OLT. Okay. One port of OLT is going to receive so many customers' traffic. Okay. Now here a separate method has to be adapted. Okay. So that particular technique is nothing but the time division multiple access. Okay. So what it means is each customer is given some time, one at a time, because when you are receiving, because otherwise if everybody is transmitting simultaneously, okay, if everybody is talking simultaneously in a class, or see what happens, it will be a total collision, isn't it? If a single listener is there, if total, it will be a collision. So that's why if all are transmitting simultaneously, the signal will collide and the receiver will not be able to understand. So that's how this particular principle is followed, the time division multiple access for upstream. So whenever it is told to so and so transmit, it will transmit, it will receive, okay. So likewise, every end device will get its own share of time for transmitting. Okay, so that particular principle we call it as a time division multiple access for upstream. So this is how here the speeds. In the case of a downstream, you achieve 2.488 gigabits per second, it's shared. And similarly, in the upstream, so each customer can transmit at the rate of 1.244 gigabits per second, isn't it? As far as the upstream is concerned. So it's a tremendous power of this particular optic fiber is being used for providing services, data services to the customers. Now here you can understand what all the things it will be. See, basically the concept called triple play or multi-play. So what all the things it will be providing? Voice, data, as well as video. Okay, this ONT will be having, like you see, data services. Naturally, you can connect an Ethernet port to your PC and start using it. If you have a Wi-Fi device here, so many users can access internet. Okay, and similarly, you have a telephone instrument. Okay, so it will be a, see, voice over IP. Voice over IP. So voice also sent on an internet protocol as a packet. We'll be learning more about it. Okay, so that is also, so that's the reason if you have a IP telephone here, you can use voice services also. Okay, but like in the case of the BSNL, is providing voice services by using the age-old telephones also. So that is taken care by the ONT equipment itself. Okay, it is converting into pots, plain old telephone service. Okay, so for the convenience of the customer. Okay, but the other end, since it is voice, it is on IP. So the normal switches which was earlier working for the customers, that switch will not serve the purpose. So you will have a centralized switch at one particular location from where the voice services are being extended. Okay. So similarly, video services. Okay, suppose for example that's the reason you have 1550 nanometers reserved for overlay services like cable TV. So this also can be extended through this particular network. So all the three services are being, you see, you have a single connection, you have all kind of services at your house. You don't need to dependent on other service providers for this particular purpose. Okay. So this was a very small introduction about the optic fiber in the concept of a guided transmission medium. Okay. So this ends our transmission medium as such. So far we have learnt about the twisted copper pair and the coaxial cable. Now the best medium which is available right now is nothing but the optic fiber. Okay. So that's all for this particular session. So in the next session, we'll be learning more about before going for the introduction to the networking. So next episode will be the last episode as far as communication basics series is concerned. So in the next episode, we'll be learning about what is actually the circuit switching and the packet switching. Then we'll move on to our main subject called networking. Okay, so keep watching my videos, share with your friends, subscribe to my channel. Okay, thank you, bye.